Hi, this is Professor Gutierrez, and we're going to be starting Chapter 3, Section 3, where we'll be looking at the relative measure standing and box plots, which is we'll be looking at z-scores, percentiles, and box plots. Z-scores are going to be the big takeaway from this section. This is the only section that we'll be covering percentiles and box plots for a while, so let's go ahead and get started. Mainly we'll be looking at z-scores. This is a way of renormalizing a lot of different distributions. We'll be assuming that a lot of different distributions look like normal distributions and trying to see how they compare. With percentiles, you may have already had some of these. You rank in this percentile or that percentile. Quartiles you may have also heard about as well. We can talk about those a little bit later. So first off, z-scores. So this is a standard score or a standardization. You take a certain value, subtract your average of your sample, and divide by your standard deviation, or you do that for your whole population if you happen to have that, and that will give you your z-score. That will tell you how many standard deviations above your population or above your sample that you are. Right? Usually we'll get z-scores down to 2 decimal points. Right? If we start having z-scores that are below 4 or above 4, we tend to have difficulty calculating those. However, anything below or above 2 standard deviations is considered significantly low or significantly high, or significantly below the mean or significantly above the mean. Well, let's take a look at this. Comparing a baby's weight and an adult's body temperature. So a 4,000 gram weight on a newborn baby. I do not like grams for weight. Pounds are weight, not grams. They are mass, but whatever. It's okay. It's okay. I can take that. 4,000 gram weight of a newborn baby among 400 weights with a sample mean of 3152 and a sample standard deviation of 693.4. Certainly looks like less than 2 standard deviations, so I think we're good there. Temperature of 99 Fahrenheit of adults, of 106 adults with a sample mean of 98.2 and standard deviation of 0.62. Alright, so that looks good as well. Z-score for the baby is 1.22. For the adult, and body temperature is 1.29. So this is 1.22 standard deviations above the mean, and for the baby, and 1.29 standard deviations above the mean for the adult as far as temperature goes. Right. Since the body temperature is further above the mean, we would expect that this would be a further extreme than the baby's weight of 4 kilograms or 4,000 grams. The higher you go, the more significant it is, and the lower you go, also the more significant it is. Platelet counts. Alright, let's take a look at this one. Lowest platelet count of a data set is 75. Platelet counts are measured in 1,000 cells per microliter. That little letter there is a mu, it's a Greek letter. Is the value significantly low? Assume platelet counts have a mean of 239.4 and a standard deviation S is 64.2. Platelet count of 72 converted to z-score is shown to be 75 minus 239.4 divided by 64.2 is negative 2.56. So this is more than 2 standard deviations away from the mean, so that does make it significantly low. So less than 2, so is significantly lower than 2 standard deviations. So for lack of a better term, it is called this weird term here. This term, which I'm sure somebody here can pronounce, but I cannot, so I should leave it at that. Ooh. Percentiles 1 through percentile 99. Alright. Divide a set of 100 groups which are 1% of the 1% of the value in each group. Alright, percentile value is the number of values less than x divided by the total number of values times 100. Alright. So the airport value, the Verizon, cell phone data speeds listed below are arranged in increasing order. 0.8, 6.5, 11.8, 15.20, 3.1, 1. That doesn't seem increasing. Oh, increasing this way. That is a horrible way to increase, but we got them. Find the percentile for the data of 11.8. 11.8 is here. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20, 21. All right, so it is number 21. Data says less than 18. So 11.8 equals 20 divided by 50 times 100, which is 40. So 40th percentile. So 11.8 is the 40th percentile, or interpreted loosely. Data 11.8 separates the lowest 40th percent of the values from the 60th highest percent of the values. Okay, so n is the total number of values in the data set. K will be the percentile used. We're going to have formulas later, so get to know these. L is the locator giving the position of a value, 12 being the 12th sorted from the lowest, and P sub k being the kth percentile. So P sub 25 is the 25th percentile. All right, start. We're ready to start. So sort any data we have. Our data is sorted, so we're good. Compute L is equal to K over 100 times N, where N is the number of values we have. We have 50 values. K is the percentile in question. We want to find some percentile. And L will be the number we're looking at. So what number will we want to look at? Is L a whole number? It could be or it might not be. So this is our little flow chart here. Let's say it is. The value of K percentile is midway between the nth value and the next value in the sorted set of data. Find P sub K by adding the nth value to the next value and dividing by 2. This will make more sense when we actually do it. No. Change L value by rounding it up to the next larger whole number, and find the P sub K value by counting from the lowest. Okay. Alright, so once again, here is our data. Find the 40th percentile denoted P sub 40. Well, let's see. P sub 40. Well, L is equal to, let's see, 40 over 100 times 50, which gives us, should give us, what? 20. Alright. So that means it should be somewhere between, this is a whole number, so we want it to be between the 20th and 21st numbers. So the value between the 20th and 21st numbers, which is between 11.6 and 11.8, which is going to give us 11.7. So that'll give us 11.7 megabits per second. Alright, now quartiles. Quartiles are Q1, Q2, Q3, no Q4, notice that. It breaks it up into 4 things. Chop a piece of wood into 4 pieces, you only have to cut it 3 times. However, there is also minimum, quartile 1, 2, 3, and maximum. Now, there are a couple of other values that we'll talk about later, but for the most part, we'll talk mainly about these. Q1 is the 25th percentile, Q2 is the 50th percentile, or the median, and Q3 is the 75th percentile. So 25, 75 from the top, median, 75, 25th from the top. This is just for this book. Some books will describe it differently. Some books I've heard is the median of the medians. They will also sometimes use these expressions. Again, you'll read these in other books. I haven't seen these too much in these books. Interquartile range is Q1, difference between Q3 and Q1. Semi-interquartile range, rough, Q3 minus Q1 over 2. Mid-quartile range, half of the range, half of Q3 plus Q1. And 90-quartile range, P90 minus P10. I have not seen these used too much. Perhaps if you go into some place that uses percentiles a lot or quartiles a lot, you will, but I have not seen these that often. Alright, this one I've seen a bit more often. Minimum, first quartile, second quartile, median, third quartile, and maximum. Right. So 5-number summary for this. Minimum, maximum, that one's easy. Quartile 1, quartile 3, and median there. So we have all 5 of those, and that will be the 5 numbers. And then we can have a box plot. Box plot is easy. We have the 5-number summary, Q1, Q2, minimum, Q1, Q2, Q3, and maximum. Construct a line segment extending from the minimum value to the maximum value, and construct a rectangle extending from Q1 to Q3 with a line going through Q2. It makes a lot more sense when you see it. Right, this is our data. See, this is why it's called a box plot. We have a box here around Q1 and Q3 going through Q2. You have your line here and another line here, maximum. So here you can see that it is skewed to the right. A significant amount to the right as well. Right. So median here, skewed a lot to the right, but that will be your box plot. And skewedness, you can see it's not symmetric. So identifying your outliers. So this is for modified box plots. So it uses interquartile range here. We don't really use that too much here. And modified box plots, they just use special symbols at the different areas. And that is it for Chapter 3.